Greetings, loyal viewers, your old uncle here. I wanted to have just a brief discussion with you before we begin our part 2 video. And the topic of the discussion is that I'm becoming increasingly convinced that the GA-1RVT amplifier, as we're building from this schematic, never really existed in real life. Gibson never built them or sold them, and neither they or under the Maestro heading, this particular circuit was never sold to the public. Now, a whole lot of people get confused. They say, well, no, I saw like 4 of them for sale on Reverb. What they saw was a GA-1RVT. Now, let me show you how different. Look at this schematic and compare it to ours. Now, granted, the RT has a tremolo, and also it tells us that the 68K resistor is the one that's missing on our schematic, which was helpful. But so far, no one has offered any credible evidence that an amplifier with this circuit has ever been seen by human eyes. Okay, now to me that makes it actually better, because we're going to see and hear something that was dreamed up back around 1960 but was never built. Okay, I think it's like thawing out the little woolly mammoth or something. This is really a unique opportunity and I look forward to it. But let me know in the comments section if you can provide proof that one of these has ever existed. It may be, I don't know, but so far no proof has come forth. Okay, so one very interesting little tidbit, I think, here, and something for us to think about while we're building this elusive little gem. Secondly, the amplifier cabinet from Mojotone arrived, and I'm going to open the part 2 video with it and go over it from stem to stern. And I just wanted to add that I did not get this for free. Okay, this wasn't given to me by Mojotone to kind of fluff up their products. It was sold to me at about the same discount that I'm offering you if you use the code, the link in the video, and therefore I paid for it. So everything I say is honest and true, because to be very honest, brutally honest, if I didn't like it, I would have sent it back and I would have told you why. But anyway, we'll open that box in just a few seconds. I appreciate your patience. So let's get started. Well, greetings out there in YouTube land, and welcome to today's part 2 video in our series covering the scratch build of the Gibson GA-1RVT amp. It wouldn't be an Uncle Doug video without a box to open, and since our part 1 video was posted, the Mojotone Deluxe cabinet has shown up. Let's get this open. I'm really excited to see what it looks like. We're going to check it out from stem to stern. We got the flaps of the box open, and I see that they've used that expanding foam to safe pack the amp, and it's done a great job. So let's get it out and take a good look at it. You know, I really appreciate this great packing material and box, because this is exactly the way I can ship the amp when I do sell it. So thanks, Mojotone. And over here on the bench we've got the amp cabinet ensconced in plastic wrap with hardware. Let's get it uncovered and start checking it out. I'll tell you, from what I can see so far, it exceeds expectations. It's beautiful. It smells great too, which is surprising considering that it's been sprayed with lacquer. Look here at the upper back door, the cutout for our chassis, which I can fit to the cabinet now that it's arrived. Beautiful leather handle. I'll tell you, doing tweed like this is an art form. And you notice that the tweed lines are continuous at each of the junctions. This is really incredible. Obviously it's built from 3/4 inch solid pine. Got the Mojotone label, made in March of 24, so it's pretty fresh. The speaker baffle's been painted black and has the studs to mount the speaker. The material is held down beautifully. A lot of times when you're covering like this, the material will start to lift up where it's gone around a tight bend, but check this out. It is gorgeous. And here's that trick, any of you who watch my cabinet covering video, where the material splits here, they've inserted a V to fill in that gap, and they've done it beautifully. I don't know, I can't say enough. I'm really impressed by this cabinet, and especially impressed by the fact that I don't have to build it and cover it. So Mojotone, I think you hit a major home run with this one, and I appreciate you offering our viewers 10% discount using the UD5E3 code when they buy this same cabinet. Oxblood grill cloth, tight as a drum head. This is absolutely beautiful. Well, now we're ready to continue with our creation of the Gibson GA-1RVT amp. I removed the upper back door so that I could test fit the chassis into the cabinet and drill the mounting holes that will retain it. I was impressed by the beauty of the interior of the panels, where if corners are going to be cut, that's probably where it would happen, and none were cut. Every surprise so far has been a good one. So let's see about fitting our chassis into this beautiful cabinet. Step one in the installation of the chassis is to construct a pillar of the finest Madagascar ebony, and I slathered it with tongue oil, and believe me, my tongue is still sore from doing it. And now the chassis is held securely in place, and I've measured the clearances on either side here to make sure that it is properly centered. Now I'm going to install the very nice upper back door and then pull the chassis toward it so that we have a nice snug fit along the chassis back door interface. Once that's achieved, I will drill the holes in the chassis to allow the retention nuts and bolts to hold it in place. It looks to me like the clearance is pretty uniform and nice and snug, so I think it's time to mark where the holes are to be drilled for the retention screws. It's nice that the overlap of the cabinet over the chassis is about what was expected, so that our controls are pretty close to centered along the opening in the cabinet. In fact, I might have a little bit of room to label each of the controls up here at the top. And there's the chassis installed in the cabinet and held in place with the 2 retention screws. Now it's time to prep the chassis, paint it, label it, then install all of the components and begin the wiring. Before I begin painting the chassis, I think it's a good idea to go back and drill a few more holes and make a few more preparations to facilitate the assembly of the circuit within the chassis. One thing I forgot to mention in the part 1 video is the necessity of drilling grommet holes inside of the 2 terminal strips that will form the power rail, so that wires can come and go to the different connections in between the electrolytic capacitors and the internodal resistors. Also, don't forget to drill the 1/8 inch holes necessary to rivet in the terminal strips that you'll be using for your point-to-point wiring. One final step with the chassis: for those who are fearful of nuts and bolts holding ground wires, I decided to resolve that issue by arc welding a ground lug here for the power supply and a ground lug here for the amplification circuit at opposite ends of the chassis. And I honestly don't think they're going to come loose over time. Well, the first base coat of gold flake lacquer has been applied to the chassis. I'm painting it inside and out. I'll probably get 2 good coats on here to make sure that the color is uniform. This is the little doghouse that I made. I got criticized on the last build because I guess poor orphans could reach up behind the chassis and get electrocuted, and so since that's discouraged in civilized countries, I decided to build a little metal doghouse that will go on the rear of the chassis right beside the power transformer. You see the holes right there to secure it and protect those poor little orphans from that mean old high voltage. Here's the base coat I'm using. It's this VHT engine metallic, supposed to be resistant to gasoline and oil, which we know it isn't, but it's a gold flake, and it's going to be tougher than regular paint, I have a feeling, plus it can withstand fairly warm temperatures, so I think this was a pretty good choice. Plus I really like the color. Well, I think the interior of the chassis really looks nice. And now it's time to focus on the exterior. One other advantage to painting it sort of a light color like this is I'll be able to see when I'm working inside the chassis. When it was black, I mean, it was like the black hole, with no offense to Calcutta, and it was, you know, hard to see, especially with my old cataract-ridden eyeballs. So now let's flip this jewel over and do the outside surface. The doghouse is finished, and as you can see, the inside is kind of a primer gray, and I put fairly thick rubber on either end. These metal sides will be kind of near the terminal strips that have the power rail built into them, so I thought it best to avoid dead shorts in that area. I know that's a revolutionary concept, but I just thought I'd give it a try. Well, the outside has gotten a couple coats. Looks good, except for one area that we'll discuss. You can hear from that lawnmower droning in the background that I'm outdoors. I was going to spray inside on our antique mahogany dining room table, and my wife got mad at me, so I said, well, let's put some of your new blouses and dresses down to protect the table, and she didn't go for that. They say that genius is never appreciated in its own time. Okay, here's the bad spot. It's right up here. I got a little chemical reaction. My fault. And I'll figure a way to touch it up where it won't be obvious at all. I've got it inside now with the fan blowing on it to kind of force air dry it. And got a really nice sheen. I just love this paint. It goes on beautifully. It's durable, and it comes in some really nice colors. So now I'm going to start printing up the decals to label the controls here on the control panel. What we have: volume, tone, tremolo speed, and reverb intensity. So let's go in and fire up the old kerosene powered computer and get to print. I've applied several coats of satin clear to the chassis, and as you can see, it's looking nice and satiny. The decals are laying down nicely on the control panel. Now I think I'll just let it sit here for a while and air dry, and I think then we can begin the assembly by installing the transformers and beginning our wiring of the circuit. Speaking of decals, if you'd like more information on the type of decal I use, how I printed them, and how I applied them, please watch the pertinent portion of the preceding video series on the Sue Princeton. I went into great detail on that build, telling exactly how this was done. One addition to that is that I found that putting a drop of dishwater or dishwashing detergent in the water made a huge difference. Okay, so I hope that if you want the information, it's available. If not, we're ready to proceed. Instead of just calling this a doghouse, I thought it'd be better to make it Rusty's Ranch House. And those of you who've been watching our videos for a while will remember Rusty. He really did help get our channel well established and help build our subscriber list. And so I think it's only fair that we commemorate his memory on this very fine cover here for our amplifier circuit. The clear coat that I applied is a similar VHT high temperature satin clear, and I wanted the satin to get a little less than high gloss finish. Okay, I kind of like this. I think it looks better on the older type vintage style amplifier chassis, and it's just easier to deal with. So if you want to duplicate this finish, that's the way to do it. One other touch that I thought made really good sense is I labeled each of the tube sockets, the speaker outputs, the fuse holder, and the rectifier socket with the proper component that goes in each. And I thought that made a lot more sense, so that you can read that just from looking straight on to the chassis, rather than trying to get mirrors and crawl underneath and try to read it inside here, where it's going to be partially blocked by the speaker and just dark and hard to read. Well, I think the chassis clear coat is dried well enough that we can start installing the components within it. And at first here I'm going to rivet in all of the terminal strips that I will be using. I'm doing that because once I start adding components on the external surface, it may block my ability to properly rivet the terminal strips. So step one, let's rivet all these babies in, and then we'll move on to the tube sockets next. The terminal strips are all pop riveted inside the chassis. I also install the RCBS sockets, and over here is the terminal strip for the connection between the white wire, the 3-wire power cord, and the return on the primary of the power transformer. Down here are those welded in grounds. This is for the power supply, and over here is for the amplification circuit. And now it's time to install the 3 miniature tube sockets and the octal socket for the 5Y3. I'm going to use number 440 screws and nuts and lock washers to hold them in place. The main reason is that you cannot get, or at least I can't get, my rivet gun inside here with this lack of clearance to install the rivets. So we'll resort to the old nut and bolt technique. Well, all of the components that are attached to the floor of the amp, which includes tube sockets, terminal strips, speaker jacks and all, have been installed, and now I think it's going to be time to install the transformers, the 3 transformers. As you see, the grommets are already in place for the wires to pass through. And that's always kind of an exciting point. I think once you get transformers in it, it starts to look like an amplifier. So let's get busy. Well, things are going along well. The reverb driver and output transformer are installed with the wires running through grommets. We lift the Rusty's ranch house and we see our power rail terminal strips are installed and ready to be wired, with the grommets awaiting the passage of wires to and fro. All that's left now is the power transformer to be installed here at this end. Some viewers have expressed an interest in seeing the kitties, so I'll do that. Here's Mitzi. Remember, she's our most recent feral acquisition. She wandered into the backyard as a scrawny, muddy little kitten and has grown into a very large and furry adult female cat. We had her neutered, and she has turned out to be just a wonderful addition to the family. There you have the fully installed power transformer, and finally the completed rear wall of the amplifier chassis with all components installed. When we turn it over, we have all sorts of wire here flapping in the breeze, and to be honest with you, I'm kind of tempted to do some of the wiring. I'm really anxious to get started. It's my favorite part, but to try to clean up some of this internal mess. So why don't we start off wiring our 3 transformers. Let's start off by wiring the output transformer. I consulted the Antique Electronics Supply website and got this diagram for our output transformer. We see that the red and brown primary leads are for 5K impedance, and the red to blue primary leads are 8K impedance. In the secondary, the black is common, which is grounded. Yellow is the 4 ohm speaker output. Green is the 8 ohm speaker output, and much to my embarrassment, there was no 16 ohm output on this output transformer. I must have been looking at one and ordering another one, okay? So, rather than waste the hole that I drilled in the chassis, let's remove the speaker jack and install a switch and use that switch to make the NFB loop switchable. And you see that our circuit does indeed have a negative feedback loop with a 47K resistor that comes back here to the cathode of one of the 6EU7 triodes, the one used as a second preamp amplification stage. So we will then fill that 16 ohm hole with a little mini switch and put it in series here so that this NFB loop will be switchable on and off. I have no idea how that's going to affect the gain and tone, but we're going to find out. Step one was to remove that embarrassing 16 ohm speaker output jack, and instead I've installed a 3-position small switch. It's on, off in the middle, on in the right position, and I made a new decal for it saying that's the NFB, and it's on and on left, and right. In the center, the NFB will be off. The output transformer secondary is all wired. The black wire goes to the ground on each of the output sockets, and yellow goes to the 4 ohm leaf, and the green goes to the 8 ohm leaf. So that's finished. Now it's time to wire the primary. Now, since our output transformer offers us 2 options for input impedance, of 5K ohms for the red and brown wires, or 8K ohms if we use the red and blue wires, let's determine what is appropriate for the primary here if we use the pentode of our 6BM8 to drive the output transformer. And to find out what our load resistance is for the pentode of the 6BM8, let's consult a tube manual. Now look at the load resistance data for the pentode section of the 6BM8, and it's 5,600 ohms. So obviously we'll be using the 5K primary winding of our output transformer. The 5K primary winding in this output transformer is the brown and red wires. The blue is the 8K input. We do not want that, so I'm going to coil it up, insulate it, hide it somewhere in the chassis so that maybe someday this output transformer will be used for a different purpose and 8K will be available. Now, how are we going to wire this? Well, I'm going to wire it with the brown wire to the plate of the 6BM8 pentode, and the red wire down here to the B plus that will be produced by our 5Y3 rectifier. Since we haven't wired the power rail here yet, we cannot connect the red wire between the output transformer and the B plus, so we'll leave it for the future when this is done. Now we can connect the brown wire to the pentode plate, which according to our tube data, there's the pentode portion there, is pin 6. Our output transformer primary is wired, at least as far as it can be at this point, with the red B plus wire going here through the grommet to the power rail, which is yet to be constructed on the rear of the chassis. The brown wire goes to the plate of the pentode of the 6BM8, which is pin 6, as our tube handbook told us. And we see that the blue wire, the 8K impedance wire, is coiled up, insulated, and saved for another day. Now it's time for the reverb driver. Consulting the reverb transformer specification sheet, we see that the red and blue wires are the primary, which have a 25K impedance, and the black and green wires are the secondary with an 8 ohm output impedance. The schematic gives us a pretty good representation of how to wire the primary of the reverb transformer. We see here it is, the 25K winding. Remember, the wires that communicated with it were blue and red. Now I'm going to run the blue wire up here to the plate of the 6AN8 triode, and that is pin 1. So there's the blue wire, and the other wire from the 25K primary, which is red, will come over here to the power rail, which has not been built yet, but will be in the very near future. And here we see that the reverb driver primary has been wired with the blue wire going to pin 1, which is the plate of the 6AN8 triode. The red wire has been routed over here through the grommet to the power rail, which will be, as I've said numerous times, constructed in the near future. So the reverb driver primary has been wired. Now it's time to wire the secondary, which is the 8 ohm output, which will communicate with our reverb tank. To get these wires to reach, I had to add a little bit to them. Okay, so that's why you see the shrink tubing. And how they're going to communicate with the tank is going to be a little tough to reach, but it's going to be the left-hand RCA output jack, which is available for the shielded cable to connect to it here at the bottom of the chassis. Now the 8 ohm secondary of the reverb driver transformer has been soldered to the 2 leads in the RCA output jack, which will communicate with the 8 ohm transducer in the reverb tank through a shielded cable connected to this RCA socket. Now that brings up a very important issue about some peculiarities in this circuit, and we need to discuss. The peculiarity of this circuit lies in this wiring scheme right here. Now this is the secondary, the 8 ohm output of the reverb driver, and both of the leads interact with the transducer in the reverb tank. Now that's not common. Generally, when you see the other transducer, we have one lead that's hot and the other lead that's grounded. Now when you use our RCA cables with external shields, this is going to be an issue, because if both the outer shield and the inner pin are part of the circuit, it means that the shield on our shielded cable is going to be energized. It's part of the circuit. In this case, the green wire in it are continuous. Well, that's not a real safe or happy situation, and also when that happens there is no shield for the cable, so it's going to be like an antenna to pick up all sorts of noise. So I have devised a way to get around this, actually 2 alternatives, and so you can take your choice. We can either construct a shielded cable that goes to our tank, in which both of the circuit wires are included within the woven shield. Okay, it's not going to be a single element cable in which the shield is grounded. It's going to be a double element or dual wire cable in which the shield is grounded. Okay, so let me show you how I constructed a cable of this type. Here is a 2-wire shielded cable. 2 insulated wires are passing through the woven steel shield. The white wire is soldered to the tip of the RCA jack, and the black wire is welded to the perimeter of the jack, and both wires are shielded by this woven steel sheath. The sheath cannot be allowed to touch any metal part of the plug, so it'll be held back with some black vinyl tape, and then I'm going to put shrink wrap over the whole thing, and that's at both ends. You cannot have the shield touching the metal at either end of the plug. Now this is the 2-wire plug that will be going from the reverb driver transformer to the 8 ohm end of the tank. Now here's step 1 in the preparation of the 2-element cable. I have wrapped the steel sheathing back here with electrical tape, and I have spaced it with another piece of tape so that it cannot advance forward and touch the metal. Then I used red heat shrink to match the red RCA socket to coat, insulate, and stabilize the plug. Now the return wire from the tank up here to the black RCA socket is 1 element, 1 insulated wire connecting the 2 prongs, the tips, and the shield. And the shield is soldered to this outer shell. So in this case, the shield connects to the outer shell, and the inner wire goes to the tip in the red or go-to cable. There's two wires, one to the prong, one to the outer shell, and the shield does not touch any metal. So here's my set of shielded cables. The 2-wire cable is marked with red to match the RCA socket that it fits, and the 1-wire shielded cable is marked with black to match its socket. Then one final step is to connect the two shields together, the 2-wire cable and the 1-wire cable. The reason being that the shield is floating on the 2-wire cable. It has no ground. By jumpering it or connecting it to the 1-wire cable with a grounded shield, you are therefore grounding both of them and protecting the signal that passes within the cable from any sort of external noise. Now, if you can't find 2-wire shielded cable, now what I've used in the video here is stuff that I've had for years. I have no idea where I got it, and I have no idea where you can get it. If you can't find any, then here's a good alternative. Simply use 2 individual single-wire shielded cables. One of them you'll strip and connect the central insulated wire to the prong of the RCA plug. The other one will be soldered to the external shell of the plug. The metal shielding will be pulled back and retained like I showed you with the 2-wire cable. Black vinyl tape, super glue, whatever works for you. And then I think the shrink wrap over the outside is a good idea. The final touch is you will solder at some point kind of close to where they connect to the plug, solder them together, the 2 shields, and then solder the shield of the 3rd or the single wire black plug that is the return, so that all 3 shields are soldered together, and therefore all 3 shields will achieve ground. Okay, that's the final step. Then of course check everything with an ohmmeter and make sure that you haven't caused any short circuits. Here's a diagram of my red 2-wire cable. You see that there are 2 wires running within the shield. The shield never touches the metal RCA plug. One of the wires goes to the prong in the center. The other wire goes to the external ring. The black shielded cable is the standard, where the shield is actually soldered to the outer shell, and the central wire, which is insulated, runs to the pin. Then with the jumper between this shield, which is floating, and this shield, which is grounded, grounds both shields and protects the music signal that's passing through the wire. Here's the alternative method: 1 shielded cable to the pin, the other shielded cable to the outer shell, then link the 2 shields together and jumper it over to the shield on the regular black cable, in which the insulated wire connects to the pin in the center, exactly like this one. And in both cases, the shield is grounded. And I should add, after you've finished constructing these cables, be sure to test them. Make sure you have continuity from tip to tip, shell to shell, and that there is no internal shorting between the insulated wire and the outer shield, regardless of which type of cable you choose to make. And here's our old friend Jack who's around 9 years old now, and he's another feral addition to the family. It turned out to be a very valued member of the family. He's here sleeping at the foot of the bed where he likes to spend his days. Now the other two kitties are sleeping in inaccessible places, so I'm going to save them for the next video. There are two important final points to make about wiring the reverb tank. Number one, be sure that the 8 ohm output RCA socket is insulated from the chassis. If you look here, both of these sockets are connected to a fiber board which is riveted to the chassis. There is no contact anywhere between the outer shell or the inner pin of either of these sockets and the chassis itself. Okay, they're floating. Now it's critical on the red 8 ohm. It is not critical on the black return socket. If you want, you could just screw this one right to the chassis because it's going to be grounded inside anyway. Number two, you have to be sure that the 8 ohm RCA socket on your reverb tank is insulated from the tank body. I'll show you how you can tell that. Look over here. This is the return transducer, and if you see this little clump of solder right here, what they've done is solder across an opening in the printed circuit that connects the grounding shell of the RCA socket with the rivets that hold all this to the chassis. So if you see that little solder bridge, that means this is a grounded RCA socket, and over here we see there is no such solder bridge, so this is an insulated RCA socket, and it's in the right position for us. If you use the tank that I specify in the parts list and in the video itself, that's the way it comes. This will be an insulated socket. Okay, nothing has to be changed if you use this tank. Now it's time to wire up the power transformer. It's a little more complex because there's more connections to make than there were on the other transformers. There's also some decisions to make. First off, this transformer offers two different high voltage levels. If you use the red wire, you're going to get 325 volts. If you use the red and white wires, you're going to get 275 volts. I think the 275 is more appropriate for this particular circuit. So I'm going to use the red and white, and here they are right here, red and white, and I'm going to connect them to the plates of the 5Y3 rectifier. Now it's real hard to see here, but if we look at our tube manual, we see that the plates are going to be pins 4 and pin 6. So I will be connecting the red and white wires to pins 4 and 6 of the 5Y3 rectifier socket. And here we see that the 275 volt red wires with the white stripe are soldered to pins 4 and 6 of the 5Y3 rectifier. Next, let's ground the center tap of the high voltage winding. We see that it's a red wire with a yellow tracer. A little refresher is that all of the electrons in the B+ circuit, the high voltage circuit, that travel all through the components of the amp, return through the chassis to this center tap. So it has to be a good, solid, reliable connection to ground. And what better way to do it than to connect it to the welded ground lug that I added while building the chassis. We see here, there's the yellow tracer on this red wire. It comes around and it is securely grounded to that lug. I think some of you are not accustomed to building amps have to agree. So far this doesn't seem very hard, does it? You have to be careful and pay real close attention to what you're doing, but this isn't a kit either, and we have no instructions. We're just going through and doing what the schematic dictates, and just taking a little time and being careful. And I think if you're willing to do that, you can build one of these. Next, and it's virtually impossible to see on this schematic, let's move over to this diagram. Let's connect the yellow 5-volt winding wires to the cathode of the 5Y3, and that is pins 2 and 8. And we look in here, we see pin 2 and 8 is way in the back, and the wires are securely connected. Okay, so at this point, the rectifier is completely wired. It's just the 4 wires that go to it, and then eventually from one of the lugs, either 2 or 8, we will take our B+ up here to our power rail. Now let's wire the primary circuit of our transformer and leave the 6.3 volt filament circuit for last, because it's probably my least favorite of all the wiring chores. Okay, here we go. We have 2 wires. The polarity doesn't matter. They're colored black almost always. It's pretty universal. And so let's discuss our wiring scheme and then wire them up with our 3-wire power cord. Step 1 of wiring the primary circuit is the installation of a really nice stout Carling on, not on power switch. There are 2 different ways to wire the primary circuit. The first way to wire it is to bring in the black wire of the 3-wire power cord and run it to the toggle switch first, then in this case, 1 amp fuse, and then on to one of the 2 black primary wires of the power transformer. The white return wire is brought into a terminal strip and then connected to the other black primary wire from the transformer. The green grounding wire is brought in and connected securely to the chassis to ground the chassis. The second method of wiring the primary is identical in every way except the fuse is placed before the toggle switch. Other than that, the return and the chassis ground are handled exactly the same. The positive aspects of the fuse first circuit is that if some sort of a short were to arise within the power toggle that somehow energized the chassis of the amplifier, and there is the mandatory chassis ground wire present, sufficient current then will flow to ground through that short circuit that would blow the 1 amp fuse and stop the short from drawing current. The negative aspect of this circuit, say you have the switch closed, you're performing, playing your guitar, suddenly your amp goes dead. You go over to the amplifier and you turn off the power switch, and leaning down, putting one hand on the chassis of the amp, which remember is grounded, you unscrew the cap of the fuse holder, reach in and grab the exposed end of the fuse, and the fuse is not blown. You then will be electrocuted. So the false assurance that opening the toggle, that turning off the amp would protect you from electrical shock is not provided by this method. The fuse is always hot as long as the amp is plugged in. Okay, so to some people that's pretty scary because you might forget this in, say, during a performance, and in your haste to get over here and turn off your amp and check that fuse, you're liable to get electrocuted. Okay, that's the downside, and I already told you the upside. Now the second method, with the toggle switch first, fuse second. In this case, if the toggle switch develops that short circuit to the chassis, the current will flow, and the 1 amp fuse is on the far side. So the 1 amp fuse is not going to blow to stop the short circuit. Instead, the 15 amp circuit breaker in the junction box in the house or building or wherever the amp is plugged in will open and stop the flow through the short circuit. So the comparison in that respect is you've got a 1 amp fuse protecting you here, a 15 amp circuit breaker protecting you here. Now that would seem like a liability for the toggle first advocates, but then let's consider something about that 15 amp circuit breaker. What protection is provided every time you turn on a light in your house? What protection is provided every time you turn on your stove? What protection is provided every time you reach in and turn on a metal-bodied lamp? And finally, what protection is provided for your household appliances? Well, in every case, it's the circuit breakers in the junction box in your home. None of these devices have another lower value fuse in the AC line that goes to them. So if a 15 amp circuit breaker is adequate protection for virtually every electrical device in your home, why is it not adequate protection for your amplifier? Now let's counter the drawback that was seen with the fuse first wiring scheme, and that was the possibility of electrocution even with the toggle switch in the off position. In this case, we're playing at Wembley Stadium with the toggle switch closed, playing our hearts out. The groupies are going crazy, and all of a sudden your amp goes dead. You run to the amp, open the toggle switch to turn it off, just as this person did, reach in, grab a hold of the fuse with the other hand bracing on the chassis, remove the fuse. It's perfectly fine. It isn't the fuse in this case. Put it back in the holder, close it, you're not electrocuted. Okay, I would consider that to be a major plus of this wiring arrangement. Okay, in this case you have 1 amp fuse protection, but a risk of electrocution even with the toggle switch off. In this type of wiring scheme, you have 15 amp circuit breaker protection against a short circuit, and once the power toggle is off, the entire amplifier is not energized, and everything including the fuse can be touched or accessible without risk of electrocution, as long, and this pertains to both circuits, as long as the filter caps have been drained in both circuits. Okay, that aspect is the same regardless. And so with that, hopefully objective presentation of the pros and cons of each wiring method. I'm going to leave it up to you to decide which one you think is the right choice for your home-built amplifier. Good luck. And there we have the primary circuit wired with some slack in the green ground wire, so that if the cord gets pulled, that will be the last of the three power cord wires to disconnect. In preparation for the final wiring of the power transformer, which will be the 6.3 volt filament circuit, I have installed the pilot light with that color changing LED. The green wires from the 6.3 volt winding have come up here to pilot light lugs. Then from the same lugs I have come out with the same green type of wire and tightly twisted. It's going to come down here to these two terminals, and from that point I'm going to convert from this big heavy type of wire to a finer smaller gauge wire, tightly twisted down here to provide the filament voltage for the three miniature tubes. And here we see the 6.3 volt AC filament wires tightly twisted to reduce hum, brought over here to these two terminals, and now I'm going to convert to a smaller gauge of wire to run from here to each of the filament pins on the three miniature tubes. I think it's time to construct the long-awaited power supply, and in preparation I have run the B plus from pin 2 of the 5Y3 socket up here and through the grommet on this red wire to the two terminal strips that are attached on the rear of the chassis. Let's flip this over and construct that power supply. And I soldered the red wire over here to what will become our B plus terminal strip, and a black wire over here to what will become our ground or B negative terminal strip. This black wire now will go down into the chassis and be soldered to our power supply ground terminal. And there you see it soldered securely to that ground lug. Now let's take a look at exactly what that power supply is going to consist of. Here is the red wire that I just soldered to the terminal strip. We see that before it goes to the primary of the output transformer and to the plate of the 6BM8 pentode, there is a 20 microfarad electrolytic capacitor to ground to smooth the ripple out of the B plus. Then we'll go through a 1K resistor and a 10 microfarad filter cap before we feed the screen of the same 6BM8 pentode. Now as we continue further, we encounter a 22K internodal resistor, which will be feeding the plate of one of the 6EU7 triodes, and we see that it is smoothed by a 10 microfarad filter cap to ground. Now that would be the end of the filtration as far as this circuit's concerned, but after I got some input from a viewer that made a lot of sense, I'm going to add a 10K internodal resistor in this line, another 10 microfarad filter cap before I go through this plate resistor and supply the B plus to the plate of the 6AN8 triode. Okay, so this will be an improvement, I think, in the circuit to reduce any chance of ripple and also to help stabilize the tube. Just to simplify things, I've drawn a layout diagram of what the two terminal strips will end up looking like. You see that we have internodal resistors between each of these subsequent terminals. We have 10, 10, 10, and a 20 microfarad cap to ground the black wire that I just added. And we see where each of the nodes is connected. The first one goes through the output transformer primary to the 6 BM8 plate. And really, I think it's a good idea to write down the pin numbers so you can double check and not end up connecting to the wrong terminal on the tube base. 1K internodal, then we're going to go to the 6 BM8 screen, which is pin 7. 22K internodal resistor, and off we go through a plate resistor to the 6 EU7 upper triode plate. That's this one right here, and we see that that's pin 6. And then this is the added 10K internodal that I'm going to add to the circuit. We'll go through a plate resistor and we'll go to the 6 AN8 pentode plate right here, which is pin 6. So that's how the wiring will proceed. Well, our B+ power supply is finished and ready to start adding wires in here to the 4 different voltages that are available at these terminals. You see right now that the red wire from the output transformer is connected right here on the right side of the 1K resistor, and on the left side I have connected the red wire from the primary winding of the reverb driver. Now the other connections for the 2 plates and other portions of the circuit will come through the grommets and connect to this power rail at the appropriate terminal to get the proper voltage. Everything's wired to the right of the 1K resistor, so let's go just to the left and let's run a white wire from the left side of the 1K resistor up to the pin 7, which is the screen of the 6 BM8. We'll start from right here, the left side of the 1K resistor, run that white wire through the grommet and go to pin 7 of the 6 BM8 socket. There's the white wire connected to the left side of the 1K resistor. It passes down through the grommet to the circuit inside the chassis. Now I'm going to show you a little secret that you can use with your point-to-point wiring to cut way down on the length of wire that you use, the chances of 60 cycle hum, and also the number of passes that have to go through these grommets, and also will make for a much neater looking final circuit. And that is, rather than take every wire that we need from the power rail on the other side of this wall and running it through those grommets down here and trying to connect it to everything, we're going to bring the white wire down to one of our terminals and solder it there. Then every wire that is needed that would connect with this white wire doesn't have to go through the grommet up there to get a connection from the terminal strip. It can come down here, a much shorter run, and make its connection on whatever terminal I attach the wire. Let me attach it and then we'll proceed and you'll see how this works out. Here we see that white wire coming in to our chassis and rising up and being connected to this terminal right here on the right side of the front terminal strip. Now, although it's difficult to get a good angle on this, I used white wire everywhere that the voltage being supplied by this wire was utilized in the circuit. And as you can see, it's going around to the tube. It's coming down this line here and being used by multiple components. Now let me just draw a quick diagram to show you why this is way better than the alternative. By bringing the white wire through the grommet and down here to this terminal strip, it's as if I brought this terminal of the entire power supply down here and made it accessible to all of the components in the circuit that need that particular voltage. Okay, we know that that would not be a good idea because the power supply creates all kinds of electromagnetic fields that cause a lot of disturbance in our circuit and possibly noise. So I've brought the voltage here, but I have not brought the noisy power supply down here. Now, with very short leads, I can distribute the voltage to each of the components that needs it, and the short leads make for both a neat appearance, but also for reduced possibility of noise and ground loops and the like. So determine where the power supply voltage is needed, then deliver it to the terminal strip or strips that will be utilizing it. Then you can pass on that voltage through very short connections to all of the components. Now let's take a few moments to discuss the rather unusual grounding scheme that I am using in this circuit. As you recall, I have a signal ground lug welded to this side of the chassis. Now what I'm doing is using green wire consistently to carry the ground to each of the terminal strips. If you notice here, the green wire is connected to this lug, and over here it jumpers right across to this lug, and this one here brings the ground to the left-hand lug on the front terminal strip, and the one in the rear is coming over here to the first lug on the central terminal strip. Now what that does for me is, rather than rely on the riveted or bolted connection between the terminal strip and the chassis, I am providing hard wired grounds to a specific terminal in each of the terminal strips, and I will use it as ground. So I have what amounts to a distributed star ground system. This will be the origin point for the star grounding, and I will distribute ground to each of the terminal strips to which I will. So with a rock solid ground being provided at one end of the terminal strip and the appropriate voltage being applied to the other end of the strip, we have everything necessary to create a fully functional sub-circuit on this terminal strip. And then after each of the terminal strips has been constructed, they will all work together to form, hopefully, a fully functional amplifier. Well, that about does it for this part 2 video in our series documenting the scratch build of a Gibson GA-1RVT amplifier. To be honest, the circuit has proven to be far more complex than I expected, and the rather claustrophobic little chassis has been making progress go a little more slowly than I anticipated. So there's a good chance this will be a 4-part series instead of just a 3-part series. So for now, I want to take the usual few moments to thank our Patreon patrons and PayPal contributors for keeping us on the air and commercial free for another month. If you'd like to join them, I will put links in the video description which will enable you to do so. As I said in the prologue, if you have any irrefutable evidence of the existence of a GA-1RVT Gibson amp, please share that with us in the comment section. Barring that, I will see you in part 3 where we continue to construct the circuit of this elusive little gem, and I'm hoping that you'll join me and watch as every spellbinding moment takes place. Until then, farewell, stay healthy, and stay tuned.